Welcome to the Deep Dive. You ready to dive deep into the history of information?
Always ready to explore.
Awesome. Our listeners are super curious about this one. They want to know, not just what information but, its power, how it's evolved, and how it's shaped the world, really.
It's a fascinating journey, for sure.
It is. So get this, we're going to uncover some seriously surprising historical connections. We're talking about a link between the invention of the telegraph and the birth of Queen Victoria's second son.
Oh, yeah, some real aha moments coming in.
Okay, so to kick things off, we got to start with the OG of information theory, Claude Shannon.
Ah, Claude Shannon, a legend. But you know what's funny? He almost called information uncertainty.
Wait, really? Uncertainty? I
Yeah.
mean, doesn't information usually make things more certain?
You'd think so, right? But that's where John von Neumann comes in, another brilliant mind. He suggested entropy instead.
Entropy. That's a head-scratcher. Isn't that, from physics? Disorder and randomness?
Exactly. It's all about disorder, and that's what makes it so profound. Information actually brings order to the chaos.
Okay, I think I'm starting to see it. More information, less uncertainty. It's like information gives us a map to navigate the world.
That's a great way to put it. It reduces entropy, helps us make sense of everything.
Okay, so we're seeing information as power, but how has that power actually shaped human progress, on a grand scale?
Well, look at the 20th century. The population exploded from about 1.5 billion people to over 6 billion in just a century.
Whoa, that's a huge jump. What happened?
Advancements in science, technology, and you guessed it, communication. It all played a massive role. Think about things like penicillin, the pacemaker, the artificial heart.
Yeah, that's true. Those were game changers for sure.
They were. They totally changed the game, drastically reduced mortality rates, and improved overall health.
It's easy to forget how much progress happened in such a short time. But were these breakthroughs, all because of a few lone geniuses?
Not quite. While we celebrate individuals like, say, Fleming for discovering penicillin, we often forget all the other people involved.
Right, all the researchers, technicians, the people funding the research.
Yeah.
A whole team effort.
Exactly. Progress rarely happens in isolation. It's like a symphony of collaboration, with teams building on each other's work.
And what makes that collaboration possible?
The ability to communicate effectively, to share information quickly and clearly.
Which brings us to the communication revolution. But you mentioned earlier that it has roots going all the way back to the 16th century, is that right?
Yep. That's when scientists really started digging into electricity.
Oh yeah, like those ancient run-ins with electric eels.
Shocking encounters indeed. But it's the 16th century when we meet William Gilbert, the guy who coined the term electricus, from the Greek word for amber.
Electricus, that's a cool word. So did Gilbert's work directly lead to, the telegraph and all that?
Not directly, no, but it laid the foundation.
Got it.
In the 17th and 18th centuries, there were tons of fascinating experiments happening. Scientists were trying to figure out how electricity worked, its properties.
Like Benjamin Franklin. With his kite experiment, right?
Yeah.
To prove lightning is electrical?
Exactly. It was a huge moment. We learned about positive and negative charges. But there's another experiment from that era that's kind of crazy. It involves a bunch of French monks.
Monks? What were they doing with electricity?
Well, they helped a scientist named Jean-Antoine Nollet. They had this mile-long chain of iron wire hooked up to a battery.
Okay.
And they all got shocked at the same time.
What? Why would they do that?
Nollet was trying to see how far and fast electricity could travel. It was a pretty wild way to do it. But it showed that electricity could go long distances and seemed to do it instantly.
Wow, that's incredible. So this crazy experiment with monks actually gave us clues about long-distance communication.
You got it. It was a stepping stone to the telegraph, for sure. People started to realize that electricity could send messages way faster than a messenger on horseback.
So we've gone from electric eels to shocking monks, all in the name of understanding electricity. And it all leads to this communication revolution. It's wild.
It really is. And it shows how these discoveries that seem totally unrelated can come together to make something revolutionary. That's exactly what happened with electromagnetism.
Electromagnetism. Okay, tell me more about that.
Well, it's the fusion of electricity and magnetism, right? And it's the foundation of so much of our technology today.
Okay, I'm with you. So who are the masterminds behind this fusion?
Well, we can thank Hans Christian Ørsted and André-Marie Ampère. They were the first to really make that connection between electricity and magnetism. And it opened up a world of possibilities, like the electric motor, for instance, thanks to Michael Faraday.
Hmm.
And then there was Georg Ohm. His mathematical analysis of circuits gave us Ohm's law.
Wow, so many breakthroughs. But earlier you said that this wasn't quite enough to kickstart the modern communication revolution. What else was needed?
We needed someone to kind of tie it all together, someone who could see the big picture. Someone like James Clerk Maxwell, this Scottish scientist. He came onto the scene in 1859.
Clerk Maxwell. Okay. What made him so special?
He wasn't afraid to think outside the box. He applied statistics and probability to physics.
Statistics? Probability. In physics. I kind of see why Einstein was a fan. But how did this help with communication?
Well, it all started with gas, believe it or not. He used stats to figure out how gas molecules are distributed, like based on their speed. Then, a year later, he applied the same idea to light. And that's where things get really crazy.
Okay, I'm intrigued. What happens with light?
He figured out that light is a form of electromagnetism.
Hold on. Are you saying that light, the light we see, is connected to electricity and magnetism?
Exactly. It was a game changer. It totally changed how we understood light and electromagnetism. And you know who was really influenced by this discovery?
Let me guess. Einstein.
Yep. He was a huge admirer of Clerk Maxwell. He said Clerk Maxwell could see beyond the noise of complex systems and find the underlying patterns.
So instead of getting lost in the details, he zoomed out to see the big picture.
Exactly. And, that's how he came up with the idea of the electromagnetic field. He focused on the overall relationships and used statistics to describe them.
So he found a way to filter out the noise and focus on the signal. That's brilliant.
It really is. And that idea, that approach to science, it's had a huge impact on our world.
It's amazing to think how one idea can change everything. Speaking of change, let's talk about Einstein and his incredible year, 1905.
Oh, 1905, his miracle year. He started with the photoelectric effect, proving that light can be both a wave and a particle.
Right.
Then he tackled Brownian motion, remember that? The random movement of particles in a fluid.
Didn't that have something to do with proving atoms exist?
Exactly. He used Brownian motion to show that matter is made of atoms. It was still a debate back then. Another example of using statistical reasoning to understand the world, right? But he didn't stop there. That same year, he publishes his theory of special relativity, a total game changer for understanding space, time, and gravity.
And of course, we can't forget his most famous equation, EMCFC.
Right. And that explains how energy and mass are interchangeable. It's had massive implications for everything from nuclear physics to how we understand the universe. So here we have Einstein, right? Building on the work of Clerk Maxwell, using statistics to revolutionize physics. But while all this was happening in theoretical science, there's another story unfolding the story of the engineers.
This is what I love, seeing how these different fields connect. So what were the engineers up to while the physicists were busy with all this?
They were hard at work, trying to translate those theoretical discoveries into actual technology.
Right, like they were trying to figure out how to actually build the telegraph.
Exactly. People had been trying to achieve fast, long-distance communication for a while. Remember Claude Schopp? He invented the tachograph, later renamed telegraph.
Oh.
It used mechanical means to send signals, no electricity involved. It was kind of clunky and expensive, but it showed that people really wanted this kind of technology.
So the idea was there, but the technology wasn't quite ready.
Yeah, exactly. They needed a reliable way to make and send electrical signals across long distances. Lots of experiments were going on, but nothing reliable had really emerged yet.
Sounds like the early days of any new tech, right? Trial and error, trial and error. So what was the missing piece? What made the telegraph finally possible?
Well, a few things came together. Alessandro Volta's battery from around 1800 that provided a steady source of electricity. And then Thomas Edison's light bulb in the 1880s that gave us a simple way to detect current. But even before that, in the 1830s, there was Joseph Henry.
Who's Joseph Henry?
He was an American physicist. He discovered that you could send electrical signals much further by using a bunch of small batteries connected together.
So more batteries, longer distances.
Exactly. And, Father Gil Cook, one of the telegraph pioneers, he eventually teamed up with Charles Wheatstone, who'd figured out how to use Henry's discovery to build a system that could send signals over several miles.
Okay, so now they have the technology. But how do they convince the world that the telegraph is more than just, a cool gadget? So we've got these inventors, right, racing to perfect the telegraph. How did they prove its worth? Show the world that it was more than just a science experiment.
Well, it took some pretty dramatic demonstrations. Morse, for example, after tons of setbacks, finally got funding to build a telegraph line between Washington and Baltimore.
Okay, yeah.
And to really prove its worth, He transmitted the names of the Whig National Convention nominees from Baltimore to Washington.
Wow, talk about high stakes.
It was a total gamble,
Hmm.
but it worked
Yeah.
perfectly. Silenced all the doubters, really set the stage for the telegraph to take off.
What about Father Gilcook? What was his big moment?
Oh, his system was used to announce the birth of Queen Victoria's second son. Wow.
Yeah. And, the news spread like wildfire. Suddenly, everyone was talking about this amazing technology that could send news across huge distances instantly.
So these two events, one in the U.S., one in England, they were kind of turning points for the telegraph.
Totally. They showed the world just how powerful information can be when it's transmitted quickly and efficiently.
So the telegraph was finally ready for its close-up.
You could say that. And what followed was this explosion of growth. Telegraph lines started crisscrossing the U.S. and Europe, connecting cities and towns. It was like the world was shrinking.
That's incredible. It seems like people really embraced this new technology.
They did. And, as these telegraph networks popped up, the idea of connecting them became irresistible. So the first international connection happened in 1849. Pretty soon, messages were flying between London and Paris. Then the big one, the transatlantic cable, in 1858, connecting Europe and North America. A few years later, a cable linked India to Europe via the Persian Gulf. It was becoming a truly global network. It's mind-boggling how quickly the world was changing, all thanks to the telegraph. But I imagine there were still some limitations, right?
Oh, of course. The telegraph was revolutionary for its time, but it wasn't perfect. Messages had to be encoded and decoded using Morse code. That could be slow, and sometimes errors happened. Plus, the system relied on physical wires, which could be damaged.
So, room for improvement. But still, it's clear that the telegraph really laid the foundation for all the communication technologies we use today.
Totally. It sparked this chain reaction of innovation. So in the late 19th century, you get the telephone, allowing people to actually talk to each other over wires, no more clunky Morse code. Then the 20th century brought radio, television, and eventually the internet, all building on the telegraph's legacy and pushing the boundaries of information transmission even further.
It's amazing how far we've come, from those early experiments with electricity to the global reach of the internet. And it's all connected by this fundamental need to share information, to connect with each other, and understand the world around us.
It really is remarkable, and it all comes back to the power of information. Our ability to access it, share it, process it quickly and effectively, that's been driving human progress throughout history.
So wrapping up this deep dive into information and its evolution, it really makes you think about how we relate to information today. We're constantly bombarded with it at a pace that would have been unimaginable a few decades ago.
That's so true. We need to be more mindful than ever about the information we're consuming. Think critically about its sources and use it wisely, right, to shape our understanding of the world.
It reminds me of what we talked about earlier, Claude Shannon and information as a way to reduce uncertainty. The more informed we are, the better equipped we are to deal with, the complexities of the world.
Exactly. And as we keep developing new technologies, as we push the boundaries of what's possible with information, we have to remember the lessons of history. Progress is rarely a solo act, right? It requires collaboration, open communication, and a willingness to build on what came before us.
This has been such an incredible journey. From shocking monks to the birth of the telegraph and the rise of the internet, we've seen how information has shaped our world and how it continues to push us forward. And who knows what amazing innovations are just around the corner, right? How they'll change the way we communicate, the way we interact with the world. It's an exciting time to be alive. Thanks for joining us on this deep dive into the world of information. Until next time, keep those minds curious.